The true photos were obtained by NASA's Perseverance rover. Since its arrival on Mars in February 2021, Perseverance has been collecting samples, measuring the environment, and taking pictures to search for evidence of microbial life. The Jezero crater, a 28-mile wide depression caused by an impact, has been the focus of the rover's explorations. An old river previously flowed across the area. The odd site captured above was likely created through millions of years of geological action associated with that river, in a build-up of boulders and sediment known as delta, as captured by Perseverance's Mastcam Z camera on June 12. If there was ancient life here, it would probably have left behind some sort of proof. Stay till the end of the video to find out about key objectives of the Mars mission. Welcome to our channel, where we provide you with facts related to space and technology. Before heading on to the video, make sure to like this video, subscribe to the channel, and hit the bell icon so you will never miss any of our updates. The Perseverance rover, which has only been on the planet for 10 months, has already discovered a lot of things. These discoveries are groundbreaking and provide more evidence that life may exist on Mars. Today's video will examine the most recent photographs showing evidence of life on Mars. According to some discoveries, there is a lot of water at Mars. The longest and heaviest rover on Mars, called Curiosity, is around 3 meters long and weighs 900 kilograms of optimism and spirit. The 1.6 meter long and 174 kilogram Mars exploration rover, in contrast to previous rovers, Curiosity's landing was very large in size and was not cushioned. 3 tethers from the spacecraft's body, known as the Sky Queen, were used to pull it to the ground. The mission scientists had previously assumed the stratified rocks photographed by Perseverance were sedimentary, but the rover's most recent discovery reveals that the bedrock it has been driving over since landing was previously produced by volcanic lava flows. Perseverance's rocks have also indicated that they have interacted with water several times and that some of them contain organic molecules. The consequences of these discoveries for our understanding of Mars go beyond helping scientists establish a precise time period for the events that took place in the Jezero crater, the location of an ancient lake. The finding was made during the autumn conference of the American Geophysical Union in New Orleans. Perseverance came to the capture of this photograph of the Jezero crater in April, where experts have been debating for years whether the rock in the crater is an igneous rock generated when lava flows cool or a sedimentary rock composed of layers of debris deposited by an ancient river. When the rover explored the crater floor, it discovered signs of igneous or volcanic rock. Perseverance has discovered rich sedimentary rock layers during its second campaign to examine the delta over the past 5 months, adding to the story of Mars' ancient temperature and ecosystem. The California Institute of Technology's Perseverance project scientist, Ken Farley, described Kodiak as a flat-topped hill with ancient, stratified wild rocks in a statement. "I was beginning to despair that we would never find the answer when Perseverance began scraping away at the surfaces of rocks with a drill on the end of its robotic arm. The smoking gun was the crystals within the rock." Farley added that Perseverance has a number of cutting-edge devices that can photograph and analyze scraped rocks, revealing their chemistry and mineral concentration pixels, or the planetary instrument for an X-ray. One of the rocks that Perseverance sampled was given the moniker Wildcat Ridge by the mission team. The rock was probably created billions of years ago when mud and sand settled in a saltwater lake as it drained. The Sherlock, short for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, is a device that the rover uses to investigate the rock's surface. According to Sananda Sharma, a Sherlock scientist at NASA's Jet Propulsion Laboratory in Pasadena, the rock zapping laser serves as a fancy black light to find compounds, minerals, and organic materials. The organic materials are most likely stable aromatics or carbon and hydrogen molecules linked to sulfates. Sulfate minerals, which are frequently discovered wedged between the layers of sedimentary rocks, preserve the knowledge of the wet settings in which they evolved. The organic molecules on Mars are useful because they reflect the elements that make up life, such as carbon, hydrogen, and oxygen, as well as nitrogen, phosphorus, and sulfur. Some organic molecules can be produced through chemical processes. Therefore, not all organic molecules need life to make them. One of these tools is lithochemistry. Perseverance identified the rock as Brock, and Perseverance utilized its tools to study it in November. During the investigation, significant olivine crystals surrounded by pyroxene crystals were found, suggesting that the rock originated from volcanic lava flows. The team is now trying to figure out if the olivine-bearing rocks originated from a cooling lake of lava or from a subterranean chamber of lava that was later exposed by erosion. We're still trying to interpret what Farley said, but I think that this is not the original crater floor. Based on the diameter of this crater, we expect that the original crater floor was far deeper than where we are now. Although the original crater floor is below the rock they are now driving over, he thinks that lava may have poured onto the crater at some point. Over time, these materials interacted with water to generate new minerals. The minerals in the samples can provide details about the climate and environment on Mars thousands of years ago. As well as the makeup of the water, Perseverance has collected 4 rock samples so far, with the potential to gather up to 37 more. Upcoming missions will return these samples to Earth, allowing them to be thoroughly examined in a variety of ways, and the Jezero crater and its river delta samples could show whether or not. When volcanic rocks are brought back to Earth, they may be dated quite precisely. Therefore, scientists might use these new samples to help them determine more accurate dates for features and events on Mars that will reveal if the water was there in the past was perhaps livable. California Institute of Technology's Kelsey Moore is a geobiologist and a postdoctoral scholar research associate in planetary science. Organic compounds were discovered in the rock by the rover's Sherlock sensor. Organic compounds are not usually indicative of previous life signals or biosignatures, abiotically, which implies without the necessity for biological processes. In a statement, Luther Beagle Sherlock, a lead researcher at NASA's Jet Propulsion Laboratory in Pasadena, noted that since the Curiosity rover, which landed on Mars in 2012, had previously discovered organics in the area where it had landed, this helps us understand the environment in which the organics evolve. However, further study is required to determine how these organic compounds came to be. Their presence gives scientists hope that they will eventually learn how they came to be. According to Brienne Horgan, an associate professor of planetary science at Purdue University, and a member of the Rover expedition, the vehicle-added Perseverance has also been using its ground-penetrating radar equipment, the first of its kind to be tested on Mars, to peer into the subsurface and assess the structure of rock under our wheels. As the rover drove across a ridgeline, the experiment was carried out on numerous rock formations with varying rock structures. It had a wonderful year in 2021, and it'll be going on to an even more exciting area next year, the old river delta. For years, scientists have been attracted by this fan-shaped structure, and Farley thinks that the rover will arrive at the delta in 6 to 8 months. The delta's rocks are likely sedimentary, capturing and conserving precious layers of silt from the river that once flowed into the crater's lake and teeming with life. A key objective of the Mars mission of Perseverance is astrobiology, particularly the hunt for signs of ancient microbial life. The rover will study the geology and climate history of the planet, paving the way for human exploration of Mars, and be the first mission to collect and bring back Martian rock and regolith, or broken rock and dust. After NASA missions in collaboration with the European Space Agency, these sealed samples would be collected from the surface of Mars by a spacecraft, which would then return them to Earth for additional research. The Mars 2020 Perseverance mission is a component of NASA's Moon to Mars exploration strategy, which also includes the Artemis lunar missions to assist in getting ready for eventual exploration of Mars by humans. Tell us your views in the comment section. If you have reached this far, like this video, subscribe to our channel, and press the notification bell so you may not miss any future updates. See you in another video. Until then, take care.